Another example. Please pause, read the question, and determine what you think the answer is. So we have a block of mass M on the floor of an elevator that is moving upward at a constant speed. So we want to relate the force due to gravity and the normal force on the block. So my free body diagram is going to be the dot. The dot represents the block itself. The block is feeling the force of gravity pulling downwards. That's the weight of the block. Because the block is sitting on the floor of the elevator, it is experiencing a normal force that points upwards. Now again, I'm not drawing this to scale per se. When I draw my vectors out to represent my free body diagram, I haven't yet taken into consideration the motion. And so please don't think I'm drawing it to scale. To determine the scale in terms of answering the question, if N, the normal force, is bigger than mg or smaller than mg or the same as mg, that requires analyzing the motion. No matter what, we know the acceleration of this block, up or down, in the y direction, is determined by the net force in the y direction divided by the mass. We can say the net force in the y direction, we know n points upwards. The normal force points up, force of gravity points down. So we can plug that in if we want. We can also reason it through. So here, this particular problem tells us the elevator is moving upward at a constant speed. So again, we need to revisit what we learned in the last section. If the velocity is constant, so it's moving upwards, that's the direction, constant speed, that's what tells us the velocity is constant. That means the acceleration needs to be 0. The velocity is not changing. If the acceleration is 0, the net force needs to be 0. So the normal force needs to balance out mg. Solving this right here shows us this. But just conceptually, recognizing that the acceleration is 0 is what allows us to know that we need to balance those forces in the y direction. So in this particular case, the normal force will equal mg.